Hi all, this is Mohammed Abu Khair from AppSec Untangled, and welcome to the solution of the second challenge in our secure code review series. This is where we have full applications with issues based on real-world vulnerabilities, and the challenge is to identify, exploit, and fix these vulnerabilities. And we're not only going to be sharing the solution, but also the methodology that we used to find it. So if you haven't attempted the challenge yet, now is a very good chance to pause the video and try it. The link is in the description. Otherwise, let's get to the details. Before getting to the challenge itself, let's just share a quick reminder of how this works. So we have all of the challenges in this directory here, and that's the one that we're going to be working on today. We have the third challenge also posted, so please give that a try if you want to. The solution is going to be posted around 20th of August. And we have also the solution in this directory here. So everything we're going to share today is also going to be recorded in this file. And all of the new challenges and all of the new solutions are recorded as releases. So if you want to get notified whenever we post a solution or a new challenge, just go here to watch, custom, and choose releases, apply. And this way you are going to be getting a notification every time a challenge or a solution is posted. Okay, so with that out of the way, let's get to the second challenge and try to solve it together. So this was a professional profile, so a LinkedIn-like website, more or less. So this is how it works. Here are some information about it. So we use JWT tokens and so on. And basically, we want to identify the vulnerability. So let's start by just following these steps to run the application. So obviously, we go to the directory. We need an M file, so this will have some secrets, and then we start it. Obviously, it is recommended to actually change the values here in production, but just for the sake of the demo here, we're going to use the default values. So I'm going to go and just paste these 3 commands. And now we have the application running. So if we go back here as well, you see that we also have a web UI. So you can go register. So like, let's say, new user. We go here. And now we log in. Okay, so now we have logged in. We can see the profiles of other users, and we can create our own profile. Test file. We can add like work experiences and so on. So that is like my profile, and if it is public, everybody can see it. So it seems we can make it private as well until we maybe edit it in, let's say if it's a draft or whatever. So it seems this is how it works. But it also seems if we go and log out, you can see the profiles. So like the profiles are accessible even to unauthenticated users, which seems to be by design. So you can see anybody's profile. But to create your own profile, you need to log in, and there you can create it and edit it. So this is more or less how it works. Now, before we try and identify the vulnerability, let's quickly remember the methodology that we are suggesting for these challenges. So the first step that we're going to start with is understanding the application scope and architecture, basically how the application works. Identifying the entry points is the second step. So that's every place where we accept user input. Identifying the dangerous things is the next step as well. So this is any kind of function or library which could change the behavior if user input reaches this function or library. So for example, an SQL query could lead to SQL injection, HTML could lead to XSS, commands could lead to command injection, and so on. So places where behavior could be changed by user input. And then we want to build a threat model where we look at 2 categories of threats: business logic vulnerabilities. So we're going to apply these at each and every entry point, every place we are taking user input, like for example, our backend routes. We're going to make sure we have the proper business logic controls like authentication, authorization, and so on. And for all of the dangerous things, we are going to add threats related to source to sink or injection vulnerabilities. So SQL injection for the SQL queries, command injection if we have commands, XSS for HTML, and so on. So all of the dangerous things that we identify, we're going to add threats for them and try and then based on that threat model, identify the expected mitigations, what should be there, and basically if something is missing or broken, we go to the next step where we try to actually prove that it is broken by exploiting it. And once the exploit is successful, we can now also suggest a fix that fixes the vulnerability without breaking the use case or how the application. So this is the methodology that we are going to follow, and that's exactly what we are going to do for this application. So let's have a quick look at this. So this is where we have the application. So we saw that we start this with Docker Compose. So this, like Docker Compose, is a good place to start. We can say that we have two containers, the application and the database. This is a Mongo database. So this is a NoSQL database. So this is the two containers we have. And the application one is built from the local directory. So we can move to the Docker file. This is basically how we build and run the application. So we're installing some packages. We are then basically installing this requirements.txt file. So this has some packages. So it seems Flask is going to be used for the backend. Then we have some libraries for the JWT. This, I assume, is going to be the password hashing and so on. And we have some other things that we can look at as well. So this, for example, ReportLab, we can probably look it up. So this is a PDF generation library, and probably this is what we use to. So if you go back here to new user, password 123, you will notice that you can download your resume here. So when you do that, so basically this is how it looks like, just based on your like profile. So it seems this is what we're using for the PDF generation. So this is an interesting thing. And again, like these are the main ones. Let's go back to the Docker file. So we install these things, and then we run Python app.py. So this is where the application code is. That's the entry point. So again, this is a Flask application as we expected. So we use Flask. If you're not familiar with Flask, you can quickly check the documentation, but you can easily see here that we have different routes, each using a different like HTTP method and path. So this, for example, clearly is the one we use to register a new user. We have one to log in. We have one to list all of the profiles. We have one to check your own profile. We have one to create a profile, one to get the details of a profile, one to edit it, and one to delete it. And this is the one probably that is generating the PDF. So again, we have these main parts of our, these are going to be the HTTP routes. And again, if we go back to the README, here you're going to see some curl commands dealing with all of these different HTTP paths and methods, and some example curl commands on how to use the backend for this one. And obviously, if you, again, just use burp or just check network tools here, you're going to see all of these backend routes being used. So this is how the backend works, more or less. If you go back as well, here you're going to see we have the first route here. This is where we have the web UI. So this serves the static file index.html. So this is probably the front end code or the HTML. Okay, so this is a static file that loads a JavaScript file. Okay, and it seems this is where like the actual logic of the UI is happening. So you can see, for example, here, if you look this function here, API, which calls the backend API. So it seems it's adding an authorization header. So we now know that the backend uses like an authorization bearer token for the JWT, and it adds some headers for content type and so on. And then it takes the body from the parameters and then sends this request using the built-in function fetch. And if you go to any of like these things, like for example, like let's say my profile, so like this gets your profile, this adds like a list item, and then it runs this function, and this function basically just uh, goes and appends an item profile. Then you get obviously a profile for this one as input, which you just add. And if you go back here to this profile, it is given also as input here. So if you look for this one, you'll find it used another place. And this profile here, so we're just going through the profiles, and the list of profiles you call the backend. This profile is my, and you just like get the list of your profiles basically, and then just go through that list and show it in the UI. So just like this was one example of how the UI works. We probably can go through everything, but the pattern is more or less the same. Okay, so we can also see that we have some, if you go back to the application itself, we have some middleware. So for example, some of the routes are using this authentication token thing. And if you look at this comes from the middleware file, so we can go there. And this is where the authentication logic is happening. So we'll probably need to have a look at that. And then also if we go back here to the PDF generation route, you'll see that we have a function called generate resume. So this is also coming from this PDF generator file. So we can go here. So you'll see this ReportLab library that we saw in the requirements.txt file being used here. And basically, we are just generating which something that looks like markup here. So it seems we're just like putting the company, role, location. So just generating something like that looks like HTML more or less. And we are just building this or generating the PDF based on this input. Okay, so this all looks interesting. So let's go back. This, I think, for the first step, we know like the backend library. We know like that we're going to be using MongoDB. The part probably that we can check is the access to the database. So again, if you go back to the application, you'll find that we are using a user store and file store to write to the database, and this comes from this store file. So if you look go to definition to this store.py file, every function that uh, deals with the database is in this file. So we just like connect to the database here, this Mongo database, and then we just, for example, get user by username, get user by ID, and we're just like using some built-in functions to deal with the Mongo database. So let's go back here to our solution template. Okay, so we know the library we're using to generate the JWT, the one we use for generating the password hash, and the one we use to generate the PDF. And we understand the flow of how this works, where the backend is, where the UI is, where the PDF generation or the database interaction is, all of the routes included. So we have a good understanding of how the application works. So now it's time to go to the next step. So the entry points, so obviously we have the web application, but also the backend routes, which we already have the list of. So we have a registered login, list profiles, create a profile, get my profile, get a specific profile, and so on. So these are the ones we saw in the app.py file. So we know the entry points and the dangerous things. So we saw that we are dealing with a NoSQL database here. So the Mongo functions or the Mongo queries are probably one thing we want to have a look at. We also have the HTML or the DOM of the UI, specifically when we are modifying it using that JavaScript file. So this is another place that we could end up with something like XSS. And we saw that we're also like using this PDF generation library with like some markup in it. So probably want to include that as well in our. Okay, so we now have the list of entry points and dangerous things. So we move to steps 4 and 5, identifying the threat. and also verifying the mitigations. We're going to combine these two steps into one. So let's start with the first category, business logic vulnerabilities. So we can probably talk about authentication. Now is a good time for us to verify how authentication works. So we can go back to the code. So let's have a look at how, let's say, the registration and the login works. So when you are registering, you get from the request body the username and the password. So you first check whether the user exists or not. And again, this is just like by querying the database for the username. So you just try to find whether the username exists in the database or not. And then you generate a password hash using bcrypt. So this is a good hashing algorithm for passwords. And then you create the user in the database. So again, if you go to the definition, this just basically inserts one with username, password, and created at. So the typical flow for registration. Now, more importantly, the workflow for login. So this is where we also get the username and the password from the request body, and we then first of all make sure that the user doesn't already exist in the database. Or sorry, we make sure that the user does exist in the database, and then also we get the hashed password, and then we check whether it is the same as the one provided, or we compare the password hashes. And if this all looks good, we give back a token in the request. And obviously, it seems that we need then to take this and put it in that authorization header. So we give that back as a response. And if you look probably at the JavaScript file, you'll see that this is basically what happens. So if you go here and let's look for something like login. So this is where you send the login request with your username and password. And if this works, we take this data and we run this function set auth. So if you look at set auth, this basically takes the token and then puts it. Okay, so we also set it in the session storage to use it later. So this is also another interesting finding here. So we just take this, and obviously when you are clearing auth, we remove it from the session storage. Now the session storage should only be accessible to the session. So this is obviously enforced by the browser, but the point is we have this, and now we can take this token, and then when we are building in the API here, we want to take this token. We basically just probably pass it to the API when we are using it. So let's try and find out where exactly this is happening. So we can see that this is in this the session storage. We have the token and we have the user ID. So now we want to take this. We want to send and we want to send it. And this token just probably is, let's see exactly, is it coming directly from, so yeah, probably like all of these things that do require authentication are just making sure that this token does exist. And if so, they just set this token thing to, yeah, so like set auth just sets it to the token that we get. So probably this is just used later, as far as I understand. But the point is, we take, so it's not a cookie. That's the maybe the key finding here, that it's not a cookie. We just take it from the session storage and we put it in an authorization header. Okay, let's move back to whatever we were doing before. So okay, so it seems like the authentication login or the login logic here, and also how we use it from the JavaScript is clear. But now let's see whether that's enforced in the back end or not. So that's the other next step. And we already saw that all of the like routes that need authentication. So for example, this doesn't need authentication because you can list profiles even as an anonymous or unauthenticated user, as long as they are not um, private. So we can see here we are only getting the public profiles. We can probably quickly check this. So yeah, just like we're listing things where is private as false. So that's how it should be. This one does require, so you're seeing your own profile. So this does require, so use this middleware similarly for like the other ones here. This one doesn't because you can get a profile ID as an unauthenticated user as long as it is either public or your own private. So that's like, again, we're checking here if profile is private. We may want to make sure that the current user, so that's the authenticated user ID as we're going to see, is the owner of this. So again, this doesn't require authentication, but it just, if the user is not authenticated, they cannot access the private ones. But the other ones do require authentication. Now, let's see how this authentication logic works. So again, we have this decorator here, and again, it checks for the authorization header. It takes this, splits this to get the token from second part here. So it's just like ignoring this word bearer, which usually is just uh, added as a prefix. And now we just do JWT decode. The secret key is in the .env file we created here. So obviously need to change this in production, but the point is we just take this. We have a set algorithm, so like using something like none or skipping the verification as well will not work here. So again, we do that, and then we just, if everything, if this decodes well, or like if the signature is fine, we don't have an expired signature or an invalid token, then we set to the request the current user and the current username as we saw. So again, the authentication logic looks good here, and the middleware itself is attached to the right routes. So I don't think we have any authentication issues here. In terms of authorization, there are two different things. One related to private, to access to private profiles. So we already saw that when you are listing the like listing all of the profiles, when you are not authenticated, you are only getting the public ones, and when you are getting specific ones, you want to make sure that if it is private, you are the owner. So this looks fine. The other one as well is IDOR. So if you know the profile of another user and you want to get it when you are, like, let's say, so the ones that do get a profile ID, look at this here. We can look at these separately. Um, so if you look here, this is the one that gets it. So this one doesn't have authentication, but again, we get the public ones, which is fine, or we get one that we own. So no IDOR is possible here. Here, when you are modifying or deleting one, you'll find this thing where like we want to make sure that the current user, the authenticated user ID, is the profile user IDs, and this is something we get from the database. So we just read it from the database. We get the user ID. So like again, you need to be the owner to be able to edit. Similarly, you need to be the owner to delete. And obviously, you can test all of these things with Burp. You can just get like edit something and then try and change the profile ID in the path and make sure this is working. So the ones that do get a profile ID as well have proper ownership checks. So IDOR is also mitigated here. So we don't have IDOR, we don't have private profile exposure. CSRF as well is kind of mitigated by design because we are not using cookies. CSRF mostly relies on the fact that the cookies are stored and automatically sent by the browser, but we are not using cookies. We are putting things, we are sending this as a response and sharing it in the session storage. And the JavaScript needs to read it uh, from there or set it as a variable and use it from there. So this is something that doesn't happen automatically when you just send someone a link and they click it. So because we're not using cookies by design, CSRF is also mitigated. So business logic vulnerabilities, the first category looks fine. Let's move to the second category or the second type of vulnerabilities, which is injection or source to sink. So we talked about NoSQL injection. So the places that we are taking user input and passing it to a query is first of all the username. So when we are checking, when you're going through the login logic, as we saw, we get the username. Uh, Now, again, if you think about how NoSQL injection works, you probably just replace the username with an object instead of a string, and it is acting as a filter. So, for example, anything that's not equal to null. But the thing here is that after we get the username, we get that user's name's password, and we compare it to the hash. So even if we do get another user's uh, profile, if we don't know the password, we are not going to be able to exploit this one. So we don't have like a very strong mitigation. Obviously, we can make this a little more robust by adding something that makes sure this username is a string, or even adding like a pattern constraint or so. But the point is, even if we don't, it is not exploitable as an injection vulnerability because you still need to check the hash. The other one is with the profile ID. Sometimes you are querying the database with the profile ID, but this is always coming from the path of the HTTP request, and this cannot be an object, so this is always a string, and we will also pass it to this function here, object ID. So this also will not uh, allow um, anything other than a string of the expected or one of the expected values or patterns for object ID. So again, we cannot really use that for NoSQL. So this looks fine. The other thing is the stored DOM, so like the XSS basically in the JavaScript file. So the thing is, if we look back at this JavaScript file and we look at the examples that we saw, whenever we are adding something, so we saw that we are, let's take one example here. So for example, this public profile item, right? So we are adding here for like to the HTML some uh, the text of some public profiles. So what happens if we add an XSS payload there? So let's see what happens. We are just creating an element, a list item. We're appending this here, and then we have this function. So we put the ID, and then we have, let's take something like the bio, for example. This is where the bio of the profile is going to be added. And you can see here we are using text content. And we saw in the previous challenge that this is a safer function. So if we look at it here, so this is a way to add text in a way that is HTML escape. This is safer than in inner HTML. So if you look for that, this is obviously like vulnerable. If you use inner HTML, this is the one that is definitely vulnerable to XSS attacks. But where this is like a much safer one because this renders it as text and it does the proper HTML escaping automatically for you as a built-in function. So this looks safe. So if we look here, we are going to see that we have this text content thing here. So if you look, you'll find that we're extensively using this one. But if you look for the other dangerous ones to add, so inner HTML, or I'm not using any of these here. So again, it seems that we are fine. And we also have another security in-depth thing, which is we are adding the CSP header here, which basically is identifying where JavaScript can run from, and it doesn't have like unsafe inline or so, which could allow XSS. So we have specific places. We have script source, self, and that's the only place where you have JavaScript. So this looks like like your own JavaScript file is the only place where you can run JavaScript from. So even if you do add XSS, it's not going to run or is going to be blocked by the browser by just applying this CSP header here or the CSP policy. So anyhow, we have this as security in depth thing. Okay, so let's move to the last dangerous thing that we identified, which was this PDF generation. And this is a place where frequently we see vulnerabilities and different types of things. And we already know the function that's being used by that. And what we need to do right now is check whether we have any known vulnerabilities. So I have many open source vulnerability scanners. I'm going to use Grype for this one. I already have it installed. So I'm just going to another directory. Okay, so we're now in the directory. We can use Grype. So you have many other ones. Privy is another one, and Sneak, obviously. But like, I'm gonna stick to the open source one. So Grype is an open source vulnerability scanner. As it runs, I'm gonna quickly show you documentation as well. So it's an open source thing. It does like container scanning, open source package scanning, and many other things. So it's a very useful utility in your toolset. So we're just gonna check this ReportLab function, and you can see here that this does have a high severity vulnerability. So if we look this one up, so let's just look at this thing here. I'm just gonna take the vulnerability ID, try to look it up. Yeah, so let's have a look at the CVE itself. That's the CVE. So yeah, so was it about RCE or like code execution? So this already looks very serious. If we look at this, yeah, let's just read it in more detail. So yeah, allows attacker to execute code by supplying a crafted PDF file. Okay, so this looks serious. Now let's maybe see like the POC for this one, like just so how this can be exploited. So we have this here, and this does have a POC, and it shows us that okay. So what's happening here is you have this payload, and in this payload you can like run code, or you can just like run a command, like creating a file called temp exploited in this case, and you just put it within a font tag here, or so basically yeah, you need to put this payload and do it. So, and this is in this add paragraph thing, which is basically just adding stuff to the content, which is then gonna be so I'm gonna take this content and we are gonna basically build it. So let's see how similar that is to what we are doing. So if you go to PDF generator, again, we're getting the bio and the work experiences and all of these things. We are building the story, and we are then, so you can see this story, then we are appending stuff to this story, and then we are building the story. So that's exactly what we're using. So the point is that the vulnerable function is the one that we are using. So it seems if we are able to add this payload in any of these things that we are adding here, so for example the bio, or like for example here the company, they're all location, so a lot of like user inputs are being put into this append here. So I'm just going to probably put it in the bio, and we can run this command using, we already have a working payload we saw in line. So okay, so now we have identified the threat or the vulnerability that is potentially there, and now we move to the next step, which is trying to exploit it. Okay, and we already have the payload here. So all what I need to do is just copy and paste this, but put it in the right place in our code. Okay, so let's move back here to the exploitation steps. So we already have the POC. Okay, so let's start by creating the payload. I'm just gonna copy and paste and do the exact, obviously if you want to run another command, you just replace this part here in the payload, but I'm just gonna do this here. Okay, and just create this payload file. Okay, so this is the payload. We haven't done anything with it yet. Now we want to register a new user. So we have this. Obviously, you can do that from the UI as well, but I'm just going to do it from here. Let's call that attacker 2 because I probably already have this user. Okay, so now we have created the user. We have the user ID. We now want to authenticate and get a token. So let's do that as well. So we have attacker 2 here. Okay, make sure this token. Yeah, so we have the token for this user. Perfect. Okay, so now we want to create this user or create a profile for this user using this payload. So basically, you're just going to use this command here, which builds or adds this, just like encodes the file properly for the HTTP request. So I'm just going to copy this, put it here. Okay, so let's try to go to the website right now. Here and just like log out, go with like attacker 2 password. Okay, so now if you go to our profile, you're going to see that this is the profile that we created with the payload here. So what we need to do now is just download the PDF. So again, we can do it with the curl command or just do it here and save. Now, the resume itself is going to be created here. We see the word exploit, but the real proof here is that this command has run, and we can verify whether the command ran or not by just running this on the container. So this is just lists the file to make sure that this worked. So I'm just going to do that. And yeah, you can see that this file has been created. And you can see that this is like 1 minute ago. So this is when I actually generated the PDF. So now we have this. Now, obviously, you can do like a reverse shell or much more dangerous things, but now we have full remote code execution. Okay, so we now know the vulnerability. So it is in our one of the packages. And this is a very good reminder for us that dangerous things don't just live in our code. It can live in any other layer of our application. In this case, like dependency or an open source package that we are using. So this is the thing. And also, it's a reminder that you could have a package with the known vulnerability, so something like Grype or any open source vulnerability, Dependabot or whatever can help you identify and fix these packages or patch them to fix the vulnerabilities. But also, it is possible that you would have an unknown vulnerability. So if you want to fix this, you want to be prepared for both situations where, let's say, you have a version that has a vulnerability that doesn't have a CVE yet. So you want to be also careful with what kind of input you pass to these things. So the fixes here, obviously patching is the instant fix, but the more robust is, first of all, having this process to run an open source vulnerability scanner and patching the vulnerability. So having a scanning and patching process for open source packages that have vulnerabilities is one thing. Specifically, the ones that take user input, like in our case, the ReportLab one, which generates the PDF. The other part of fixing this is managing the user input being passed to these functions. So for example, we were passing this like HTML or markup language to the library, which obviously was the reason why this was possible. If we added like an escaping function, HTML escape, to that, the payload that we used here wouldn't have been possible because like you need to have these characters passed. If these were HTML encoded, the payload wouldn't have been working. So that's another thing. And obviously, even making things more tighter by input validation, allow list of characters, a maximum length, also makes it much less likely that a payload for such vulnerability would work as well. So this is more or less, and obviously hardening the, like, again, adding security in depth. So for example, hardening the container, not running as root and so on, are things that you can do to limit the impact of this if it does happen. So this is more or less how the vulnerability works. This is the methodology we followed to find it. This is how we can exploit it, and these are the suggested fixes. So I hope you found this useful. Again, a reminder that the third challenge is already on the repo. So if you go here to challenges, you'll find this third one, and you're going to see how to also run it here and just see the UI for it and so on. So please have a look at it. The solution should be posted around the 20th of August. Good luck practicing your code review skills. And hope you found this useful. Have a great day.